Good afternoon. Thanks everybody for coming to this session on the last day of the conference today. I'm Sumati Gopalakrishnan. I'm the Senior Dev Manager, and Project Avatar is one of the projects that we manage in my team. Project Avatar, in simple words, targets the best possible options for leveraging and embracing the HTML5 technologies in the Java and Java EE world. So Project Avatar comprises of multiple moving parts, WebSockets, servers and events, and data services from the Toppling side. And most of the implementations are in progress and is available on the open source and is available in the next releases of both Glassfish and WebLogic 12.12. The main focus of today's session is to introduce the new programming model that we have as part of Project Avatar, which is basically an incubator project. It's an R&D in progress project, and it is mainly targeting for coming up with a good programming model for developing the next generation rich HTML5 based applications. So whatever we are going to talk in this session is going to kind of evolve and change, and part of this will become the Java EE8 standards. What will become is kind of yet to be determined, or TBD. But the main focus of today's session is to kind of use this current forum to communicate what we have so far, because we are at a pretty good milestone at this point of time to share what we have so that we can communicate and gather feedback from this session. In a couple of days, we had the technical keynote and we had the demo grounds sessions, and based on the feedback what we got on the Angry Bits demo, which is an end-to-end application, enterprise application that we have built using this new programming model. We have slightly altered our agenda today to mainly focus and deep dive into the technical details of Project Avatar, which is focusing on the programming model. So without further delay, I would like to introduce Santiago and Torkel, who are our couple of Avatar leads out here, who will deep dive and show the actual beef and the bun, show more details of what Project Avatar is.
Well, thank you, Sumati. Over the last few days, I've talked to some of you at the booth and in other places, especially those that were at the keynote on Sunday. And many people were asking me whether Avatar is real or it's just smoke and mirrors, or what it is. And I've been telling people to come to this talk. So hopefully today we're going to be able to put some beef into the bun, so to speak, so that you can see that it's not just bread here. All right, so this is the agenda for today. I intentionally have a very short agenda because I want to do a deep dive on the code, and so that you can see some of the demos running and we can play with them a little bit. That's sort of the feedback that I've been getting, stop showing me slides, I want to see the code. And that's what we're going to try to do today. So we're going to start with some introduction. We have to have some context before we look at the demo so that we understand what's going on. We'll talk a little bit about, what is Avatar, what's the syntax, and how we arrived to the syntax that we have now, which is still sort of evolving. And then at the middle of the presentation, we're going to switch to the IDE, and we're going to start playing with some demos. And once we look at that, we're going to go back and sort of review the architecture and try to understand what we learned from those demos. All right, so let me start with a definition. I typically don't like to read slides, but I think this slide is something that is meant to be read. So Avatar is a modular end-to-end web development framework for building enterprise, mobile, and desktop applications using JavaScript, HTML5, and a thin server architecture. As you can see, we've tried to squeeze as many buzzwords as we could in here. And I think we did a pretty good job. So I'll start with the blue parts. I think the parts that are not in blue are pretty straightforward. We all know what a web developer framework is and what's mobile and desktop and so on. So the first part is the modular part. I don't think I attended any talk where the speaker has said, we have an architecture that isn't modular. But in this case, it's particularly useful because we're talking about JavaScript. And if you have any experience with JavaScript, it's very easy to write non-modular code in JavaScript. In fact, JavaScript doesn't support modules out of the box. And you end up having really long and hard to maintain code, I think technically known as spaghetti code. So the modularity here is particularly important. The next part is the end-to-end. There are some other frameworks out there that also support end-to-end. And the idea here is we're not only going to be worried about the view part, but we're also going to be worried about the services. So in fact, an Avatar application has both. And then lastly, the thin server architecture. This is what makes Avatar different from some of the other frameworks, some of the more traditional frameworks. And we're going to try to come up with a definition for that in a couple of slides. So let's start with the modular and the end-to-end part. Basically, an Avatar application has, it's comprised of modules. Some of them are view modules, some of them are service modules. So naturally, the view modules are going to be targeted to the browser, and the service modules are going to be targeted to the server. And an application is going to contain 0 or more view modules and 0 or more service modules, which means that you can have an app that is just services, or you can have an app that is just view modules. And we're going to package all that together and deploy that application. We're going to see how we do that. And naturally, the Avatar runtime is going to look at those modules and say, OK, so these modules really belong to the browser, and I need to package them and send them to the browser. These other modules are really for registration inside the server. OK, so thin server architecture. There's a few different definitions of this. This is the one that I like the most, and I think the one that hits the nail on the head, so to speak. So let's start with the traditional model or non-TSA architecture. So in this module we have, in this model we have a view and a model there on the server side. And then we have an application running on the client, a browser typically, that requests a certain page. So what happens here is that we take the view, we take the model, and we sort of merge them together. There's sort of a marriage process here, I like to call. And then the result is what we send to the application, and the result is going to be a combination of HTML and JavaScript that the browser is going to execute for us. But the key here is that merge between the view and the model happens on the server side. Now, on the thin server architecture, that's a little bit different. I mean, we can see already from the diagram there are some differences there. First of all, we can see that the server is a little thinner, right on the diagram. Okay, so that's why we call it a thin server architecture. But the basic idea is that we take the view and we're going to essentially ship the view to the client. And then we're also going to ship the models to the client, and we're going to do that merge between the view and the model on the client rather than on the server. And doing that has a few advantages. It may have some disadvantages as well, as everything we do in computer science. But one of the main differences here is that once we download the view, especially for a small application, we can download the entire view in one shot. All the communication we have between the browser and the server is just for data. So you can see that we have an arrow for the view, which is HTML and JavaScript, and another arrow that is labeled JSON, because JSON is really the format that makes the most sense to work with browsers and the one we use by default. So the models are going to be connected with what we call services, and they're going to get the data from those services. And once that data comes to the client, then we need to do the merging between the view and the model so that we can update the application. And the way we're going to be doing that is using a technique called data binding, and we're going to get in a little bit more detail now. But the one thing to remember from this slide is the fact that the merging happens on the client. So some of the advantages there is that essentially the DOM is going to be built only once on the client. The DOM is going to have some placeholders for the data. And once we get the new data, we just go and update the DOM. We don't have to rebuild the DOM. If we do the merging on the server side and we're not using AJAX, we're getting a completely new page, then we need to build a DOM every time we get a new page. And so that's something you see latency-wise when you're using a traditional type of web server architecture. All right, so let's dive a little bit more into the programming model. Obviously, a little bit different from client and server, but let's start with the client side. So on the client side, we have extensible component views. Basically, anytime you build a modern web application, you're going to be using components. You know, it's like when you're writing in Java, you need to use a library to write your program. You don't want to start from scratch, just plain HTML. I mean, it may work for a simple application, but as soon as you get into the more business type of application especially, you want to use components. And this is something that we know from JSF and other frameworks. So we have that. We also have, we make a distinction between a component and a widget. So the component is what we define in Avatar. The widget is usually part of the implementation of that component. So in fact, we have pluggable widget sets. We can change the underlying widget set and keep the same component, and that's going to change obviously the look and feel of that component. So I'll talk about that a little bit more. And then when it comes to the models, so we saw in the previous slide that the models are going to be client side. Client on the browser, what we run is JavaScript. Therefore, it made a lot of sense to just use JavaScript for the models, and that's what we decided to do. And then we're gonna understand where the data binding comes in place when we talk a little bit about the UI style that we have. So let's leave that for later. And then naturally, we're gonna have HTML and CSS. I mean, this is part of what building a web application is all about. Now, on the server side, we have a couple of options here. So on the one hand, we can use Java EE to build our services, and in many cases, that's going to be the best option. We can use JAX-RS for the REST services. We can use the new WebSocket API to build WebSocket endpoints. But in addition to that, we thought it'd be interesting to explore the idea of using JavaScript services. The reason for that is that there are a lot of JavaScript developers out there that don't know a lot of Java. And in many cases, they can put together a JavaScript service pretty quickly to support their applications. And this is one of the areas that we're exploring. So Avatar supports the idea of services written in JavaScript. We have some simple APIs for writing REST services, servers and event services, and WebSocket services, all in JavaScript. We're running all this on the Nashorn JavaScript engine. You may have heard about this engine at JavaOne this year. It's going to be open source in the future, and it's going to be part of SE8. It's a very fast JavaScript engine that uses all the new features of the JVM, Invoke Dynamic, and all that stuff. And of course, because it is running on Java, you can also use any of the Java API you can access the Java API within your JavaScript program. And we're running all this on top of a modular system called AMD, which is becoming increasingly popular in the JavaScript community. Require.js and some of the other frameworks use it. It's a very simple model system for JavaScript, but it works really well. And we're using the same technique for both the client and the server. All right, so let's just review the concepts that we have before we run into the demo so that we can understand what we're seeing. So these are the important concepts on the client side. So starting from the left, we have what we call the UI nodes. These are what I called earlier the components. These are the components you expect to have in any web, at least modern web development framework. We have things like pages, forms, input tables, containers. Everything you saw in the Angry Bits demo, it's a UI node in Avatar. And as I said before, we make a distinction between the component or the UI node and the underlying widget that is implementing that node. And then on the right-hand side, we have our models. And this is where we deviated a little bit from the traditional way of defining models. So we decided, as we started playing with this framework, that we wanted our models to be a little bit more intelligent than the usual models that we build. In many frameworks that follow the MVC pattern, you define a model and then you define a controller for that model. So you always have to do basically two things. So in this case, we decided to say, what if our models are a little bit more intelligent? Since they are written in JavaScript, they can have methods, they can do more things than just storing the data. And as a result, we came up with this idea of saying, well, what if we have different kinds of models that you can use? And those kinds of models come predefined with some behavior that is useful for your application. And so we went ahead and defined these 4 kinds of models. You have the local model. This is a model that is not connected to any service. It can still be stored using HTML5 storage, but it cannot be easily sent to a service because it doesn't have any connection with services. Then we also have REST model for REST services, push model for SSE, and socket model for WebSockets. So what about controllers? Well, controllers play a lesser role in Avatar for 2 reasons. One reason is because of this intelligence that I just mentioned that we added to the model, so there's less of a need to create a controller all the time. The other reason is that Avatar provides data binding, and one of the reasons why you would create a UI controller many times is just to copy data from the view to the model, and in this case, that's going to be done automatically for you. But there are some cases where you do need models for complex navigation, controllers for complex navigation or for listening to UI events and things of that nature. Now, at the core, we have Avatar with the services that it provides, namely data binding, navigation. We're going to see that the type of navigation that we do, it's a little bit different, and also things like local storage, as I mentioned. And obviously, all this is going to be running inside the browser. There are no plugins or anything like that. It's just JavaScript, HTML, and DOM. So server side, similar picture, but obviously very different here. The underlying infrastructure here for running these services is Nashorn, as I already mentioned. So starting from the right-hand side this time, we have services that correspond to the models that I just introduced. So we have a REST model, a push model, and a REST service, a push service, and a socket service. And these are the ones that are going to be serving the data to the models that we have on the client. Then on the right-hand side, we have what we call data providers, and this is also an area that is still evolving, and we're analyzing how to do this right. Obviously, when you write a service, the data has to come from somewhere. It's not just there. So there are a few different providers that we're working on so that you can retrieve the data if you're implementing your services in JavaScript. In one of the examples, we're going to see the file provider, but we also have things like JPA providers and are working on a coherence provider as well. And then the Avatar core on the server side provides routing, making sure that whenever you get a request, there's the right handler for that request, either REST, push, or socket, as well as some basic serialization. As much as we could, we went with the convention over configuration style for Avatar. So we're using JSON. We're assuming serialization is always JSON unless you indicate otherwise. So that's how the server side is built. So with that, I'll move on to the syntax a little bit. We spend a lot of time talking about syntax. I always thought developers didn't care too much about syntax, but that's certainly not the case. If anyone says, I don't care about the syntax, I care about the semantics, he or she is lying. So the first thing we had to decide is whether we wanted to do declarative style or imperative style. And it turns out that they're both good and bad, depending on where you use them. At least that's the way we looked at it. So we looked at the problem of declaring the user interface first. And we thought that we play with declarative and imperative styles. And we decided that the declarative style was actually a little bit easier. It's also better for tooling. It's better for things like templating that we're going to talk about. And the main reason for that is that when you write declarative style, think HTML or XML or anything like that, you have elements that are nested inside another element and so on and so forth. And the nesting gives you containment. So it's basically establishing a parent-child relationship between the outer element and the inner element. When you have to do that programmatically, then you need to create an object and then create the other object and then say, add child and things like that. And then it becomes really boring really quickly. So the declarative style really made a lot of sense, in our opinion, for the UI. And in fact, there are many other frameworks that also use that approach. Certainly JSF has a declarative style for the UI. And even JavaFX has FXML today. Now, we also thought that there's some cases where the imperative style makes more sense than the declarative style. And for us, those cases were whenever we had to do models on controllers. So we could have gone with a declarative style for models on controllers, but then it was very hard for us to add all the intelligence we wanted to add to those things. So instead, we decided to go with just pure JavaScript for that and basically take the full power of a Turing complete language. So it's a little bit strange that I wrote what you see is what you get here, but basically what I mean here is when you're writing imperative, you look at the code and you know what's going on. Sometimes when you do declarative style, it's a little bit less, it's a little bit more confusing what's going behind the covers. And we thought that for the models and the controllers, it's really something that you wanted to know what's going on. Okay, and with that, so let's dive into the syntax. So we looked at a proprietary syntax. We looked at XML. We looked at just plain HTML. We looked at XHTML. And we still haven't looked at creating a whole new language, but I guess that's the next thing that we should look at. And we decided that at the moment, we started with XML, and I'll tell you why in a moment. But we're also investigating the HTML route. Now, as you can tell, there's an X in XML, and there isn't an X in HTML. And there's a good reason for that. XML is really designed to be extensible. You can define your own language on top of it. HTML isn't. There are some extensions now. HTML5 defines the data dash extension in a way to overcome this problem. But unfortunately, that extension is not good for structured data. It's only good for non-structured data. And we really needed the structured data extension. So we wanted the ability to use namespaces. For those of you that are familiar with JSF facelets, it looks very much like that. And we wanted the idea to mix components with HTML all within the same page, and that's something that XML allowed us to do. Now then the question is, why not XHTML? And the reason for that is that we wanted to have a multi-page format. We're going to see in our examples why we decided a multi-page format was better. So within the same XML, you're not going to be limited to defining one page. You could define multiple pages and connect them somehow. But as I said before, the HTML is something that we're still investigating. There are some advantages there. People know it. They're very familiar with it. And it's a little bit less structured than XML, obviously. Well, the Java is on the service. When you write the services. Yeah, that's right. Okay, well, that's partly true. Yeah, that's partly true. I mean, we tried to run Java on the browser before. It kind of didn't work. So, I mean, the browser is really designed to do JavaScript, and we really didn't want to introduce another layer there. But let's hold on to the questions until the end, if we may. So at this point, raise your hand if you're tired of looking at slides and you want to see some code. Okay, that's what I thought. Yeah, I'm raising my hand as well. So at this point, we're going to switch to the IDE and take a look at some samples. And with that, I'm going to introduce Torkel here.
All right, so I'm going to show you some examples to make you understand a little better what the heck he was talking about here. End-to-end TSA data bindings, what does that really mean? Let's dive into some examples. The first app I'm going to show is called Hello. And this is going to be interesting because I accidentally stopped the server before the presentation. So we'll see if it works. Okay, so this is a very...
I think you need to make it bigger.
Yeah, it might work.
Bigger.
Yeah.
No. Okay, now it
doesn't look as nice. Yeah. Anyway, so this app has 2 input fields and some labels, and then a text underneath and a button. And you can type your name in here, and the text will be updated. Extremely useful application. So, And this is a pure client application. There is no server side to this at all. It's all in the browser. And that's part of the whole TSA architecture, right? As much as possible will be executed in the client. Let's look at the code. Okay. Yeah, maybe
can you read that?
Small. Can you read it? Hopefully you can read it.
No. Can you zoom in?
Maybe I can. No. Okay.
No.
Well, you'll have to Command Option plus. No. Anyway, I'll try to explain it, and then hopefully you can see something. So this code has two parts to it. It's the UI, and then there's the data model. The UI is declarative, and declarative is really superior for building UIs. When it comes to models and manipulating data and business logic, imperative programming is more intuitive, right? And JavaScript is ideal for that. And here we're actually bringing the best sides of the two worlds together in a really nice way. And one of the main features in Avatar is the bidirectional data binding. And if you looked at the example app, when I typed my name, the text underneath was updated automatically. And looking at this code, you can't really see any logic here that does that acts on this event and updates a field and so on. And what happens really is that we're using EL, the expression language, to bind a view component to a data model, or actually it's binding it to a property of a data model, like in this case. What happens is that when I edit this text in the input field, the framework will automatically update the model, and furthermore, the model, when it's changed, it will also update all the view components, all the UI components that it's bound to. And that's why we call it a two-way data binding. Extremely powerful. And EL is here acting as the glue between the UI and the models. So let's look at next example. I can, I can try. Hang on. All right, you got the whole thing. Colors and fonts. Right, edit. Let's see. How about that?
Is that
Is that better? All right, that's good.
Can you close what you have underneath?
We can close. Yeah, we can do this.
Double click.
Well, we're going to open another file. Okay, so first I'm going to show you the app actually. The next app is called Add Sub. It's essentially a calculator. How about that? It only supports plus and minus. And now there happened to be a bug here, because in fact the result there is not the sum, but the product. And that's because I was playing around with this just before the presentation. But the point with this app is not that. It's to show navigation. This app has 2 pages, and there's a next button which takes me to the next page, which has subtraction instead. And it works the same way. And I can go back and forth this way. And for those of you who paid attention here, you might have noticed that when I go to the next page, the URL up here is actually changed. it says addition here, and then it changes to subtraction. And this is important because that actually makes the back and forward buttons work. And that's how a web app should work when it comes to navigation. So Avatar is using URLs and links for navigation, which is important. And again, remember this is TSA, which means that all of this is happening in the browser. There is no network traffic at all. When I switch page like this, it's purely in the client, right? And that's what makes this UI so fast. And that's the whole point of TSA. You give a really fast and responsive UI.
Show the code.
And actually, oh, show the code, of course. You want to see the code, huh? And sub. This is, again, just a client-side application. Again, it has the UI, it's declarative. It has 2 pages instead of 1. Here is the navigation. It's just a simple link, right, that does this for you. And then we have the data model written in JavaScript. And again, we have the EL for binding the UI components to the data model. It's, so the binding is to properties of this model, which is a JavaScript object. But we're also using EL for performing actions. And one example is the reset button here, where we're actually using EL to invoke a method on the data model. So the EL can be used for both performing actions and for the data binding.
And what is EL? Is it separate from Avatar?
Yeah, EL is a standard
Expression language?
it's expression language. It's part of what's JSR.
Java EE.
Yeah.
We have the spec lead right here.
Oh,
Right behind you, by the way.
perfect. Oh, and there was a bug here. I'm going to just show you that I'm not mocking all this. So I'm going to fix this bug. And I do Control S to save, and Eclipse will automatically redeploy this app. So when I refresh the browser, it should now be addition instead. So it's a very fast turnaround here when you develop, thanks to Eclipse in this case, and Avatar, because we're actually recompiling in real time. Or deploy time. Okay, next example. The next app is called Store. And now we're going to see an app that also has a server side. This little funny looking app shows a collection of items, and you have the possibility to delete items and add items. Oh, did I delete now? Sorry. And this collection is stored on the server. And I can show you that by starting a different browser. Store. Oops. Typo. So we have the same collection there. Yeah. So let's look at the code. We start with the server side. So this is the server side code. It looks a lot like the client side. It's XML, it's JavaScript. And so we're running JavaScript on the server using Nashorn, just like Santiago said. And this is part of our end-to-end strategy. So you have a framework which uses the same format, the same Java programming language for both client and server. And this opens up, of course, for all you web developers out there that has done HTML and JavaScript programming for your whole life and you love it. So you want to stay there, right? You don't have to leave the framework. You can build your whole app from end to end without moving to another framework or leaving this framework. Okay, and let's look at this code quickly now. I think we don't have too much time. So we're declaring a REST service, and this REST service listens to a URL for HTTP requests, and it has the option to, return in the data or do some kind of processing. In this case, we're getting some data from a database and returning this. And Avatar provides a number of data providers, which gives you access into JPA for data storage, or you can store it into a file or something like that, which makes it really easy to build a data-centric application which is processing data. You don't have to move over to Java to access the data. You can do it simply by declaring a data provider. In this case, it's storing into a file. And you can access this data provider either, imperatively or declaratively, depending on what you're doing. I'll try to speed up. So if we look at the client side, again, we have the UI, it's declarative. We have the data models, and in this case, they're REST models, and instead of the local model in the previous examples. And the REST model, when it's loaded, it will get the data from the server, and it receives the response, and it will automatically deserialize this data and update itself with that information. Typically, it's JSON data. And thanks to the data binding, this model will now populate this data to all the UI components that has a binding with this data model. And this is done using this very powerful EL-based data binding. And another feature I would like to mention, which is not in use here, so in HTML5, there is a new feature called local storage, which is useful if you want to store a state locally on the drive while you're offline. You can keep working with your application, and when you go online again, you still have the data there. And in Avatar, by simply adding an attribute called local store to a model instance declaration, we will automatically store your state, your data in this model on the disk using local storage. And when you go back online, we will automatically synchronize with the backend server data. And if there has been changes on either side or both, we will take care of the merge. And all you need to do is declare which merge policy you have. So all you need to do really is add 2 attributes to your data model instance, and automatically you will have local storage. Really powerful feature. The next example, I only have two examples left. This one is called Tickers, and it is going to demo how Avatar is using SSE, service and events. This little app, sorry, there we go, is basically pushing out data over SSE, and in this case it's stock prices. Of course, they're not real, they're just generated. And if we look at the yeah, look at the source. Again, we have our XML and JavaScript. That's all we have. And in this case, it's a push service, not a REST service. And this push service, again, it will listen to the declared URL for incoming SSE connections. And this service, based on a timeout, it will use the push context here to send this data to all the connected clients to this SSE service. This is, I should mention that. Thanks for asking. So right now we have an avatar plugin to Eclipse, which is giving us syntax highlighting for JavaScript and XML. And it also gives us some content assist and some other features like that. Well, there are some IDs that already have this. I know IntelliJ, I think, actually can do this already with their standard XML editor, and I'm not sure about.
How do they know when the JavaScript? Can we leave the questions till
yeah,
so that we can finish the demo, please?
Let's hold that question. We'll do the questions afterwards, but it's a good one. Thanks.
Yeah, just show the client and let's know.
So let's see. Here's the client code. Again, we have the view, and we have the model, and then we have the binding between the view and the model. This is a push model. Works just like the REST model. It will connect to the given URL that you declare here on your instance, and then it will receive events. When it receives the events, it will automatically deserialize the data and update itself. And then, thanks again to the binding, it will populate this data to all the UI components that is bound to this model. Okay, last example is a chat application which will use WebSockets. It has a login page, and then you log in and get to a chat room. And I'm going to use one more browser here to see if we can get some communication going. So here, excuse me, we have two clients connected to this WebSocket service on the server side, which I'll show in a second, and we can type messages back and forth like this. Yeah, you got the point.
Yeah, we need to wrap up.
So let's look at the service code. Chat service. Exactly like the other services, except this is a socket service. And you declare your URL, we will listen for WebSocket connections coming in. And here we're using the socket context to send, when we receive a message, send that message to all the connected peers. And finally, let's look at the client side of this. And again, we have the GUI, so that's declarative, and we have the models in JavaScript. This is a socket model, and it receives, it connects to the WebSocket service, and it receives events over this socket. When it receives an event, it deserializes automatically, and it updates itself, and then populates all the UI components, thanks to this powerful two-way binding. And yeah, to summarize this, TSA gives you really fast GUI, declarative UI, superior, and JavaScript for imperative logic, business logic, the best of two worlds. And we have the powerful bidirectional bindings, and it's an end-to-end language, the same language for client and server. You don't have to leave the framework. And then we're using REST and SSE and WebSockets for communicating between client and service. Thank you. And I'll be here if you want to ask, but we'll do questions after.
Yeah, that's right. Okay, thank you, Torkel. We're running a little bit late, so I'm just going to skip this one because we looked at it already. So now that we looked at the examples, it's a lot easier to explain what the architecture is of Avatar. On the right-hand side, we have the server architecture. We're running on top of Java EE, namely Glassfish 4. We have a couple of specific components from Avatar that are serving these applications. We have something called the view service. This is responsible for delivering the UI to the browser. We have the data services, which are responsible for the implementation of all the JavaScript services. As you can see, both services are connected to the Avatar compiler. The source, as you notice, is XML and JavaScript. The browser doesn't understand that. It doesn't understand EL or anything like that, so some compilation process needs to take place. And we're also using Nashorn, as I indicated before, for the JavaScript services. But of course, we're running under Java EE, so you can write this using JAX-RS, using WebSockets API, etc. On the client side, we download the Avatar application, which may have multiple pages, multiple modules even. And we custom make an Avatar runtime for that application. So if your application only uses 5 UI components, then we only send the code for those UI components. And then naturally, we're running inside the browser, which is an environment on its own, and that provides the DOM, the local storage that Torkel alluded to, as well as all the UI functionality. And you can see the communication is HTTP, or WebSockets, depending on whether we're talking about view or data. So we mentioned data binding. Data binding is actually very powerful and almost essential for any framework of this kind. The idea behind data binding is that you have the model, you have the view, and you need a way to merge them, and you don't want to write controllers to always do that because it's a very repetitive work. Avatar supports 2 types of data binding, one-way and two-way. This depends on the type of component that you have. An input component would typically be two-way. An output component would likely be one-way. There's also like a zero-way data binding, if you will, where we only have an action associated with a property. We've seen some examples of that if you click a button or something like that. Interestingly, we also support data binding for HTML. You've seen in some of the examples that we support, you can embed HTML inside those examples, and you can also use EL expressions with those examples. It's also supported in the framework, and we actually use that quite a bit. So here's an example of data binding. We have a model at the bottom called MDL with 2 variables, name and isCool. And then we have data binding with 2 different UI components. Naturally, this happens a lot. You have multiple UI components that are connected to a model. In one case, we have an output component, which provides just one-way data binding from the model to the component. You see that in the arrow. In the other case, we have a checkbox, which is actually two-way, sort of an input component. So it provides both ways, which means that anytime we update the model, the checkbox gets updated and vice versa. So we looked at models and services, and there was a little bit of magic behind all that. There were some cases where the model, like in the tickers case, was just defining the variables, but there was no logic behind it. The way we do that is we use JavaScript prototypes. If you're not familiar with JavaScript prototypes, they are similar to base classes in Java. JavaScript is not a class-based language, and therefore, if you want to add behavior, common behavior to multiple objects, you use what is called a prototype. So here's an example of how we use prototypes. We have a socket model, in this case on the client, that is redefining the on message and the send methods. We're using the convention of using a $sign in front of those to indicate that they are framework methods and they're intended to be overridden. But then there's a lot of other behavior that comes from the prototype, and in many cases you don't have to redefine that. For example, as I said in the tickers case, we were not doing any redefinition, we were just taking all the defaults. For example, the default in a model is when you get a message, you deserialize the message and you update the model. And exactly the same technology is used for the services. We have the notion of prototype for services, and this is the reason why you have to specify what kind of service it is or what kind of model it is. So in a way, what we're doing is we're using XML as metadata for JavaScript in these cases. JavaScript doesn't have something like annotations. If it did, we would be using that. And so the XML that we provide gives the framework the information it needs to set up the right prototype and the right default behavior for that model or service. So here's an example in code. I'll just go over this very quickly. On the left-hand side, we have a chat model, and we're redefining one of the methods from the prototype, and we in fact are also calling the prototype method in this case because there's some functionality that it provides that we don't want to write again, in the same way you would do super dot in Java. And on the right-hand side, we have an example of a service that, in this case, has to override this method if it wants to do anything interesting with the message that it's getting. We saw a little bit of navigation. Navigation is a little bit different in Avatar because, as I mentioned, the view can be downloaded all in one shot. It actually downloads it one module at a time, but you can have many applications that are just one module. So navigation happens in the so-called hash scheme of the URL, which means that we don't actually go to the server to get, whenever we update the hash scheme, we don't have to ping the server. And there are, Avatar supports a lot of components. Many of those components support the notion of a pane, which you can think of it as being a part in a page. And in some cases, those panes are not shown. They're not visible. For example, if you have a tab container that has multiple tabs, some of the panes may not be visible at a particular time. So if you want to make those visible, what you can do is you can use this hash scheme to indicate that you want to navigate not only to a certain page, but also to a pane within that page. In addition to that, we have parameters just like in the traditional way, and those are particularly useful. For example, if you have a table and you select an item on a table and you want to get a detailed page of that item, many applications would actually use parameters to pass that information to the next page. And in fact, that's so convenient that we define a global model in Avatar called $location that is always going to be bound to the value of this hash scheme, as it's always going to be parsing and updating itself whenever the hash scheme updates. And the nice thing about this model is that you can use it anywhere, like in a URL or in a place like that, and whenever the navigation takes place, the model gets updated, and because of data binding, so does your component get updated. So this is a little bit about the Avatar archive. At the moment, it's just a zip file. We have a top-level directory, Avatar, and then we have a directory for the view and one for the service. And within that, we have directories for each of the modules that are in the system. We don't actually have a hierarchical directories here, so we only have one directory for org.example.hello and not three directories nested one into each other. And then depending on whether it's a view or a service, we have different places to put the different components. And the reason for this is that when you're writing an HTML application, there's a lot of boilerplate that you need to generate on the client side. So by us having all this structure, we can do the generation of that boilerplate for you. For example, setting up loading all the JavaScript resources, CSS, images, and whatnot. So on the server side, we basically have this as the same structure, except that obviously we don't have CSS or images or any static content like that. In addition to that, we have a properties file where we indicate a couple of things, whether we are in debug mode or not, for example, and also the type of the widget set that we want to use. So we can go into the archive, change the widget set, and then change the look and feel of the application. And I don't think I have time to go over the advanced concepts, so why don't we open it up for questions, and if you want more detail about this, we're going to stay a few more minutes. Thank you very much for coming. So I don't think we have microphones, so if you could speak up. Yeah. Yeah, you. Say again? What are we using? Yeah, we are currently have support for 3 widget sets. We're using Dojo, jQuery UI, and jQuery Mobile.
Do you have an editor for drag and drop kind of?
Not at the moment, no. Yeah.
How easy is it to do debugging and logging like now in the digital architecture?
Good question. You have a couple of options there. One is Project Easel. Have you seen anything about it? Yeah, so that's one option. The other option is using tools that are provided in the browser. The browser already has debugging and all that. Most browsers do. So you can actually use the debugging there.
Right. So actually my question is like, now since your model is on the client side on several different browsers, but if one of the clients has an issue, like how do you know that on the server? You have to go to that client and spend more time
An issue meaning it gets disconnected or something? Or, you said a client may have an issue?
Yeah, like some JavaScript didn't work on a particular browser or something like that.
Well, that's something that you need to work ahead of time, but I don't think that's specific to to thin server architectures. I mean, even if you have a thick server and you're generating JavaScript, the client may not take it. I'm not sure who's next. I'm going to go here.
Yeah, you mentioned Dojo widgets. How does Avatar compare to Dojo? It's like an all-in-one.
Okay, so Dojo is a completely client-side solution. There is no server piece. There's no compilation of the server. They actually do have a declarative style, but they process the declarative style in the browser. It doesn't help you with boilerplating and all the other things. It doesn't have a declarative data binding or any of those things. It's more like a JavaScript library, if you will. Yeah. Yeah, we're still exploring. At this moment, all of our testing is done using Selenium. I don't know if you're familiar with it. The UI, yeah. Oh, you were talking about the services? Or? Yeah, no, we don't have anything specific for that just yet. Yeah.
So where would I put my business logic?
Good question. Good question.
Logic.
Yeah, no, you don't want to put the business logic there, right? So you put it behind your REST services. Yeah. Unfortunately, it's not available just yet. As we said at the beginning, it's just an incubator project. I don't know, maybe someday it will be. We'll make an announcement when we make it available. Does that mean that you liked it, or? Sorry, there's one there. Yep. That's a very good question. Well, we just think that there are JavaScript programmers out there that they want to have the same programming model on the server side, and there are some other. You may have heard about other talks about JavaScript on the server side. This is not the first one. So there's this thought that there's a community out there that wants to do services with JavaScript, so that we're thinking of providing as an option, as we explain here. But it's not, if you don't want to do it, you don't have to. Yeah.
Have you made any, have you added anything to EL, standard EL spec?
No. We're using, in fact, the implementation is using EL 2.2, is 2.2. We hope to upgrade to EL 3 when it becomes available that has lambdas and other cool stuff in them. But we we haven't changed EL at all. One more question. Yeah, go ahead. Okay, good question. So you mean in the JavaScript service case? Right. So JavaScript, Nashorn runs on top of Java, which means that you can access any Java API from JavaScript. There is an interface to do that. It's quite easy, actually.
So the JavaScript service implementers would then have, if they want any powerful standard library functions,
well, there are a lot of powerful things in JavaScript itself. You don't always have to go to Java. And in addition to that, we have the data providers, which in many cases are going to solve your problem without going to Java.
there's no database mechanism.
Yes, there is. There's one data provider was JPA.
Yeah, but people who come from the web, they don't know about that stuff.
That's why we provide it. That's why we give them a provider. You don't have to write it yourself. That's the whole point. It is. That's what we get paid for it.
Yeah, but you also have to support all kinds of browsers, and you need to
No, the providers is completely server side. No, it's not. No. You got that wrong. We don't. You have our own module system. We're using the AMD module system, which is becoming a standard in JavaScript. No. At runtime, the JavaScript, it's all generated AMD modules, which is AMD modules. Require.js, many other JavaScript frameworks are using it. We haven't created our own module system for that.
Okay, so
I think they're going to be posted. I'm not sure where, but all the Java 1 slides are going to be posted in the same location. Anybody knows that? Sorry. Yeah.
You guys explored any strategies for preventing scraping? Like with this model, making the data well structured, going out stripping open. So if you've got, say, a store, it's very easy for someone to figure out, oh, this is their web service, this is JSON. I'm going to now steal all their products. They may not want that.
You mean other than using HTTPS or something like that?
Yeah, other than that, like, have you been faced with any clients who are concerned about that?
Not at the moment, but as we said, we're an incubator project, so we're a little bit far from there. But obviously, SSL is going to be supported.
What's the story for the internationalization of the tools?
Good question. We actually have a story for that. Because we have a compiler on the server side, we have the ability to do I18N for you. And the way that works is all the components have, I didn't get to that slide, actually it's this one here. When you define a component, the component has a number of properties. Some of the properties are going to be of type data bind. They want to be connected to the model. Other properties are going to be more like labels. Okay? And then we have metadata in those properties that say this property is an I18 property. So when we do the compilation, we generate essentially an I18 table for you. And we can also, because we're server-side technology, when we deliver the view, we can look at the initial request and determine what's the right language to deliver to. Exactly, yeah. And we actually have a process for generating those resource bundles by just inspecting the program, so you don't have to write them by hand. So we try to avoid this style of having to use a key and then having to update a table. We try to generate some things for you.
TBD.
Yeah. Again, I have to ask you the same question. Did you like it? Okay. All right. Please send us feedback. I don't know where, but. Should we?
We can set some.
We can set something up. Twitter. I'm on Twitter. If you like it or you dislike it, or you like this part and not that part. A bit more persistent than Twitter, yeah. Yeah.
Yeah, we can set something up.
You think we can set something up?
Yeah, we can set.
I mean, don't you have like a issue tracker or something?
Yeah, but not public at this point. Well, thank you very much for staying.